Number 4, state Faraday law. So Faraday law state induced EMF is proportional to the rate change of flux, right? And number 2, a long straight wire. So this is straight wire and this is current flow to the right, is placed near to the coil. So this is the coil. If I or current is decreased in magnitude, this means the direction of the induced current and direction of induced magnetic field. Okay, so now the current flow in the wire. So if you use the right hand grip, so this is your thumb, right, and this is your finger, right, your finger here. So this is direction of the current flow, your thumb, and your grip finger is into the page at this part of the magnetic field B into the page. So if I write the direction of the B here, this is B, 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 P, P, produced by the straight wire. But the current is decreased. So according to the Faraday law, alright, or you can read it to the Lenz's law, because of I decrease, the current flow decrease, meaning the number of B here or the B strength also decrease. So according to the Lenz, okay, you must have another B, use the blue color, that can oppose, because of B is decreased, so you can oppose here, you can increase. So meaning you have I use the blue color here. The blue color is a B. B here is a B produced by induced EMF or induced current I in the coil. Because initial B is decreased, to oppose you must increase. So the direction of the B, induced EMF, induced current, is into the page. So if you use the right hand here, the grip here is into the page for the blue color, and your thumb here, so this is the direction of the current flow I. That's why the current flow in clockwise, and direction of the B produced by the current I to overcome the decreasing of the B produced by the current I in the straight wire, direction into the page, or you can refer to the blue color here. And number 2, if I is constant, so now I is not changed, constant, give the two way to induce EMF. So if the current is not changed, meaning the flux or the B passed through to the coil is not changed, magnetic field is not changed. So meaning no induced EMF in the coil, meaning no current I flow in the coil. But still you can produce induced EMF if the current constant. What you can do is you can move coil forward to the wire or away from the wire, or you can increase the size of the area of the coil, small, big, or from big to the small size. So meaning you have, if you increase the size of the coil here, so number of flux is, when the small coil, number of flux is reduced. When you increase the size of the coil, number of flux pass through to the coil increase. So you have the change. The main idea is you have the change of the flux. So you can change a flux. If the current constant, you can change the size of the coil, and the second, you can move forward or move away from the wire. From the two situation here, size and position between coil and the wire, you can induce current in the coil. Thank you.